in this chapter, we're really going to focus on looking at Earth's surface and how we describe it. So one of the most basic ways to describe Earth's surface is your location on that surface. And so one of those ways would be a coordinate system, like east, west, north, and south is an example of a coordinate system. And then your latitude and longitude. And when you talk latitude and longitude, you deal with degrees. So when describing an object's location, its direction is very important, especially if that object is moving. So a compass and a compass rose are both devices that help show direction. A compass is a device with a floating needle that aligns itself with Earth's magnetic field and will point north. A compass rose is exactly the same thing. However, it shows the four major directions. So your major directions are north, south, east, and west. Your intermediates are like northwest, northeast, southwest, and southeast. So a compass rose has both the major and the intermediates, where a compass will just have the major. So when we look at direction, it's important to understand that there's a difference between magnetic north and geographic north. Magnetic north is what the compass needle will line up with in Earth's magnetic field, and it actually shifts over time. It doesn't stay in one place. The geographic north is sometimes referred to as true north, and it's slightly different than magnetic north, and it is on top of the imaginary axis around which Earth rotates, and it will not change. So if you look at the diagram over here, the red line right here is your magnetic North Pole, and over here we have your geographic north. And so notice how there's a gap between the two lines, and that is because they're not exactly the same. They're pretty close. I think they're only separated by about 11 degrees, but they are not exactly the same. So a compass will line up with magnetic north. Sometimes, especially in ship sailing, they will use a double compass rose, and this allows users to make the correction between magnetic and true north. And so usually you can see that this line right here is pointing towards magnetic north, whereas this starred line would be your geographic north. So they can see where they're off and how much they're off, and then correct accordingly. Another important thing that we're going to look at this chapter is called topography. Topography is a type of measuring that looks at the height or depth of a feature relative to sea level. And so a couple words that we use associated with topography are relief and elevation. I'm going to assume that most of you have heard of elevation before, and this is just the height of anything. Relief is the difference in height in a landforms in a region. So let's say we have mountain A at, 5,000 feet, and mountain B is at a height of 2,500 feet. The relief will be the difference in height, so that would be the 5,000 minus the 2,500. So your relief here is 2,500 feet. So when you look at the topography, you see they get mapped a little bit different. And so you can actually see in these images, let's start with the one on the right here, the height of these mountains versus you can tell that down here is much lower. It's almost like a three-dimensional map. Another way to look at it would be the one on the left here, where you can tell that there are different colors, and the different colors are going to represent different elevations. So in this particular one, the brown is representing low elevations, where the green is going to represent higher elevations. Continents and landforms are found on Earth's surface. Continents are large land masses. There are 7 continents. They are older than the ocean floors. Some rocks on continents are billions, and that's with a B, of years old. The ocean basins extend from the edge of the continent to the ocean floor and deep into the trenches, and these rocks are only millions of years old. So if you look at this diagram, it's almost like they cut Earth in half, and we're looking at it from the side. So over here, you can see that it's really low, or it has a deep past the ocean level. And as you move up, you can see here at the Himalayas, that's a mountain range, so they're a little bit higher. And then same here with our Andes mountain range, it shows some height, and then it automatically drops back down when we enter the Pacific Ocean. Landforms are physical features on Earth's surface, such as mountains, volcanoes, plateaus, lakes, rivers, and they are made by either constructive or destructive forces. So a constructive force is any force that causes landforms to grow. So when a volcano erupts and the lava flows down the mountainside and it cools, that's going to create rock and build things up. And another example of a constructive force would be the tectonic plates crashing together to build mountains. A destructive force then is exactly the opposite of a constructive force, and it breaks landforms down. So the volcano erupting would be a destructive force, and any other types of weathering and erosion are destructive forces. Constructive and destructive forces work together to create new landforms. So for example, constructive forces build mountains, while destructive forces like weathering and erosion wear them away into like plateaus. So if you look at your diagram, here are these mountains that are being formed, and then they're getting weathered away. The weathering is happening here with the grayish color. And eventually, they get worn away so much that they level off and form that plateau. Rivers and streams flow across continents, and water is one of your biggest destructive forces. So water has the ability to cut away at rocks, and this forms river valleys. So in the picture here, this river is cutting away at the land to form that river valley. Bits and pieces of rock get carried by that moving water, and then they get deposited where the rivers meet the ocean. So right in this area, all this water from up in the high end of the mountains are carrying sediment down, and when the river meets the ocean, that sediment gets dropped off. This forms something called a delta or barrier islands. So a delta actually occurs where the Mississippi River enters the Gulf of Mexico and by Padre Island in Texas. They can bring sand to shore, which then forms a beach, which would be a type of constructive force. And you can see that a beach is forming here at the end of this delta. So the ocean basins are where the ocean meets the land. That's where they start. And then it gets divided into all these different sections. And I believe the next slide has pictures of that. The continental margin begins at the shore and goes down to the ocean floor. And the continental margin includes three things: the continental shelf, the slope, and then the rise. The continental shelf is part of the continent. That's why it's called a continental shelf. However, it is underwater, usually between 100 and 200 meters deep, and it can extend up to 200 kilometers from shore. So it can go down a little bit, and then it can go out quite a long ways. The continental slope is the slope that forms at the edge of the continent. So that would fall here, your continental slope. And then the continental rise ends at the ocean floor. So if we look here, we have the continental shelf extending from the edge of the continent. Then we have the slope. And then lastly, we have the rise, that last little bit here. Rise is labeled out. You can maybe see it up here a little bit better. And then it ends at the ocean floor, is way out here. The ocean floor goes by another name. It's also called the abyssal plain, and it's not totally flat. Back in the day, before scientists mapped the ocean floor, it was believed to be completely flat. However, we now know that there are undersea volcanoes, and those can rise more than 1,000 meters above the sea floor. We know there are mountain ranges, and they're very long and very tall. They can be up to 2 kilometers high. And there's a huge system of ridges called mid-ocean ridges, and they form from volcanic eruptions. The lava from inside Earth breaks through the crust and creates these mountains. And so right here on the map is one of those ridge systems. So anywhere where you see that green and yellow is an indicator of one of those mid-ocean ridges on the map. And we'll talk more about those when we talk about volcanoes. So again, this is showing you that the ocean floor is not flat. You can see that each one of these are seamounts or sea volcanoes. You can tell that they're kind of bumping up, kind of like a pimple. And this one is more looking at the topography of one of those specific ones. I believe it's Bear. And you can see that it rises up pretty clearly from that image. So the opposite of a sea volcano would be an ocean trench. This is now the deepest place of the oceans. Many of these are located on the edge of the Pacific Ocean. The Mariana Trench is the deepest place in the ocean. It is 11 kilometers deep, and it's located off the coast of Japan. Here's Japan, and here's your Mariana Trench. And the tallest place on Earth is Mount Everest, which is less than 9 kilometers tall. So the deepest place is deeper than the tallest place on Earth.